On the Mayfly bench, a blast from my past, this 18-year-old Mayfly acoustic guitar amplifier. So this amplifier I made got the file right here, in 2002. That's 18 years ago, and the design is for an acoustic guitar. However, this particular model was specially tweaked for electric flute. The owner of this amplifier is a very accomplished flautist and has used this amplifier on many stages around town. And he says always carries to the back of the hall. It's a very interesting piece of work, and I'm glad to have seen it again. This particular amplifier features all tube circuitry, 60 watts of power via a pair of 6L6 output tubes, a sensitivity control, all tube reverb, a tweeter and a full bandwidth 12-inch speaker, a tube driven balanced output with level control. The complaints? Well, there really isn't one. It's just here for some regular maintenance. I'm going to be replacing some electrolytic capacitors in the power amplifier section. Let's have a look. Here's the amplifier out of the chassis. There's a chassis over there. You can clearly see the tweeter, and it looks as good as when it was made. So here it is from the inside. This is pretty typical of my work from the period. I'd arrange it so I'd have the row of preamp tubes here and the preamp tubes over there. There's a big hole there. Maybe I should fill that. But other than that, it looks very clean. Nothing weird has happened. These electrolytic capacitors haven't burst or anything. They're still hanging in there. But the amp is 18 years old and we'll probably need to replace them. One of the things you may see is that I've got a distributed power supply and grounding scheme in this amplifier, which is fairly sophisticated. How it works is that the power supply nodes are distributed throughout the board. For example, here's the capacitor and the resistor that feeds power to the preamp section, and then the next section as we go down. Now, what may not be apparent is it also has a distributed ground. So it has what's known as a localized star. So all of the ground points for the first stage being fed by this capacitor are grounded to the same point, and then from there grounded further on. Everything is grounded to the bus, which runs down centrally here, and then ends up being grounded over here. I wouldn't do that these days. Instead of grounding over there, I'd probably ground it to the input jack. Right now this input jack is floating, but that's how we did it at the time. It's fascinating. Here is the amplifier with the main high tension capacitors removed. They're right here. Haven't popped yet, but we're going to remove them to be on the safe side. While I was waiting for some parts to arrive, I decided to plug that big hole there. I used some aluminum plate, custom cut and machined to fit in the hole, affixed with 4 number 6 screws. Don't think it's going to be a problem anymore. So the capacitor replacement is all done. Now it's time to fire it up and see where we're at with the power rails. As always, we have the dim bulb tester and our dummy load. There's no signal generator or oscilloscope because I just want to check the rails and see if all the supplies are about right. It's always good to have a plan in place before you begin a test like this, so you're not hunting and pecking all over the board looking for various voltages, and you make sure you test every voltage. It's also a good idea to know what sort of voltages you're looking at a particular point. To aid in all this, I've got the original schematics for this guy. 18 years old. Paper rules. So it's fairly sophisticated, actually. In addition to the various B+ voltages up here, there's also 2 bias voltages, one for each output tube, and there's a bias voltage for a cathode follower. In fact, there are 2 cathode followers in this design. One of them is driving the potentiometers for the tone controls, and the other one is driving the transformer for the balanced DI output. I've got my hand behind my back, because you always probe with one hand. I'm going to turn on the power and see what we got. All right, we have heaters, because you see the pilot light. Now time to test the first B+ voltage. The power supply rail test has passed. All the rails are where I expect them to be. Now let's hook up a signal generator and see the output. So instead of plugging in a signal generator, I got a little lazy and just plugged in a guitar. Let's see what it sounds like. So the amplifier is done. Maintenance is all complete. Here's a bag of parts, old parts, that are going to go back to the owner. And as a final test, let's do a little outro song.